हेलो। क्या बोलूं? Good evening to everyone present here. Respected Director Sir, the Head of Departments, our esteemed guest of honor, Dr. T. Gurunathan Sir, our Chief Guest, Professor Shishir Sinha Sir, faculty members, and all my fellow engineers. A warm welcome to one and all. I wish you all a very happy Engineers Day. This is Sharmila from second year ECE. We are gathered here today to celebrate Engineers Day. I consider it a great honor to welcome our dignitaries onto the dais. Our respected Director Sir, distinguished guest of honor Dr. T. Gurunathan Sir, our ECCC in charge Dr. Anup Jacobs Thomas Sir, please come onto the dais and grace us with your presence, sir. When we consider the marvels of the modern world, the skyscrapers dominating the city skylines, the bridges and highways that connect us, or even the devices in our hands that keep us connected to the world, we are reminded of the significant role that engineers play in shaping our society. So let us celebrate the commendable contributions made by engineers to the society and pay tribute to one of India's greatest engineers, Sir M. Vishweshwaraya. And now I request everyone to stand and honor our national song Vande Mataram.
वन्दे मातरम् वन्दे मातरम् सुजलां सुफलां मलयजशीतलां श्यामलां मातरम् वन्दे मातरम् शुभ्रज्योत्स्ना पुलकितयामिनी फुल्लकुसुमित ध्रुवदलशोभिनी सुहासिनी सुमधुरभाषिणी सुखदां वरदां मातरम् वन्दे मातरम् वन्दे मातरम्
Thank you, everyone. M. Vishweshwaraya, a dreamer, thinker, and a man of action, not lost in the past but always thinking of the future. Let us see a glimpse of how M. Vishweshwaraya has become the greatest engineers of all times. Anup Jacob Thomas, sir, our ECCC in charge. Sir, please.
Good evening, everyone who has assembled here for the Engineers Day celebration. And I thank the chief guest, Professor Shishir Sinha, for joining online, and the guest of honor, Dr. T. Gurunathan from BHEL, for joining here in person, and the director, Professor NVSN Sharma. Today, we are here to celebrate the National Engineers Day, which is celebrated as a memory of Sir M. Vishweshraya. So as we have seen in the video, he has actually done a lot of contributions to the country. And this country was also not built in a single day, and this institute also was not built in a single day. It has been, it has been a lot of work and sacrifices of many people, and we are here as a part of that. And sometimes when I teach students computer science and engineering, I also tell them, if we do not have electricity, we cannot use computers, and we have electricity, we have electronics, we have computers. So all of these things are interconnected, and none of these things were built in 1 day or 2 day or in a century. It took so much of time, so much of effort, and so much of dedication and knowledge sharing, which all caused this to happen. And we are here to celebrate the National Engineers Day. You are all budding engineers. You are doing your BTech right now. I suggest all of you to please concentrate very much on your education and be passionate engineers, so that you can do some things that can be very helpful for the society and for the upcoming generations as well. Thank you.
Thank you, sir, for your remarkable words. On behalf of IIIT Tiruchirappalli, I'd like to extend a warm welcome to our chief guest, Professor Shishir Sinha, sir, and the guest of honor, Dr. T. Gurunathan, sir. Welcome, sir. It is an honor to have you with us today. Now invite Nehal Chaure from second year ECE to join me in welcoming and introducing our guest of honor, Dr. T. Gurunathan, sir.
On this prestigious occasion of Engineers Day, we are glad to have our esteemed guest of honor, Dr. T. Gurunathan sir, with us today. Now, without any further ado, let me introduce you to our distinguished guest of honor. Dr. T. Gurunathan sir works in quality and business excellence at BHEL in Trichy. He has pursued his BE and ME in mechanical engineering and manufacturing technology, respectively, from the Regional Engineering College, Trichy. He has also completed his PhD in the field of helium leak testing from the prestigious National Institute of Technology, Trichy, in the year 2017. Sir joined BHEL as an engineer trainee in the QC department of nuclear products in the year 1985, and has since had a marvelous career spanning over 3.5 decades. Dr. T. Granathan sir has received numerous accolades, including the Young Engineer Award, National NDT Award for his great contributions in the field of helium leak testing. Sir has also received Excel Award from the DHEL Corporation in 2002 and Unit Level Excel Award in 2019. Not only this, but Sir has authored 45 technical papers which have been published in various national and international journals. Four of his papers have been awarded the Best Technical Paper Award. Dr. Gurunathan is a member in many professional bodies, including IWS, ISNT, IIW, ASNT, and the Central Boiler Board. So, it's truly our privilege to have you here amongst us. Now, I would like to invite Dr. T. Gurunathan to enlighten the budding engineers of today.
Thank you, Nandal. Respected Professor uh, and Director of Indian Institute of Information Technology, Mr. NVSS Sharma ji, Professor Shishir Singha, who has joined online, Director General IIIT, and Dr. Anup Jacob Thomas, who is on the dais, and my dear student community, faculty members of Indian Institute of Information Technology, a warm good evening to one and all. I consider this as a great honor and privilege to be with the budding engineers on the occasion of National Engineers Day, which is celebrated in the name of our great first engineer, I would say, first established engineer, Vishwesvaraya ji. There was no specific topic mentioned for this, for this program. So I have chosen topic which is of interest to student community. The topic goes like this: what are the indices of an excellent organization, and in the excellent organization, what are the roles and responsibilities of engineers when they join such elite companies, organizations? That is the topic I have chosen. Okay, maybe that is convenient to me also, so I have chosen, and it will be somewhat interesting to all of you. With that background, with that introduction, small introduction, let us go into the details. You know, we are seeing a lot of companies. Some companies are going up. Some companies are in the medium level. Some companies are in the bottom level. They are not known to anybody. So what are the indices of an excellent organization? So I consider that BHEL is one of the excellent organizations, and taking cues from the success stories of BHEL and similar PSUs like ONGC, NTPC, and major central government organizations like Baba Atomic Research Center. I am making some of the examples, taking some of the examples of these companies, and trying to explain what are the indices of an excellent engineering organization. Some of the things will be somewhat new to students community. Some of the things will be already known to you, and you will be in the process of learning also. The first and foremost requirement for an excellent organization is to acquire a system certification. The organizational capability is conveyed in any company to an outsider, to a public, or to an assessor who is making an assessment of the capability of an organization. It is the first and foremost requirement is a system certification. Perhaps some of you will be knowing about that. There are a lot of system certifications. Important system certification is ISO 9001. Some of you will be knowing what is ISO 9001. It is a overall system requirements. Companies, how companies, good companies have to run, how good companies have to establish themselves as the capable organization in front of public, in front of shareholders, in front of employees, and in front of all the stakeholders of a company. For that, first and foremost requirement is holding a system certification. So company has to thrive for acquiring this certification. That is the first and foremost requirement. Number two, product certifications. Whatever is the product the company is manufacturing, some of the products are major number of products, or at least the key products should have a product certification from international certification bodies like ASME, American Society for Mechanical Engineers, or British standards, or in our case, in a boiler manufacturing company, Trichy, the fundamental requirement is to have certification from Indian Boiler Regulation, IBR. Indian Boiler Regulation, it has got genesis right from 1950, when many first time boilers were installed in companies, in some process industries, sugar mills and all. It started, it has grown to very big level, and it stipulates a lot of technical requirements to be adopted in the design of boiler, in the manufacture of boiler, in the erection and commissioning of boiler, in the running of the boiler. So it's a comprehensive document addressing all the requirements. Why all such requirements are available? One is the personal safety, wherever they are handled, wherever the equipments are handled, personal safety. Second one is public safety. Third one is personal safety, means people who are working. Public means surrounding. The third one is equipment safety. So these are all and finally, of course, money, cash to the person who is running the company. There should not be any monetary loss because of accidents. So considering all these things, product certifications are available. The company who is claiming that they are excellent should have some product certifications. It can be from international origin like American, British, or Indian origin, Indian Boiler Regulation in the case of BHEL. So like that, depending upon the nature of the company. For example, in petroleum and petrochemical industries, in the companies like oil and gas, ONGC and all, they will have certifications to American Petroleum Institute, API. So like that, the second requirement for organizational capability is holding product certifications. Then process capability. It is coming to these two are system certification and product certification. These two are ensured based on assessments by an outsider, also by an insider, that is within the company. Whereas the third aspect is purely within the company, process capability. I think most of you would have heard about Six Sigma process. Have you heard about Six Sigma process? Students, are you aware of Six Sigma process? Yes or no? So what is Sigma? You studied statistics. What is Sigma? Okay. And Six Sigma process has got, it is a process. If the process is established in a company, there will be only 3.4 defects out of 1 million products produced. What is the normal 3 sigma? 3 out of 1000. Outlier. If you draw the normal distribution, within the bell curve, you will have 99.7%. So 0.3% will be the two outliers on left side and right side. The total is 0.3% or 3 out of 1000. That is 3 sigma process. In the case of a 6 sigma process, the process capability itself is 12 sigma level. In the case of 3 sigma process, process capability is 6 sigma, minus 3 sigma and plus 3 sigma. I think with the statistics, people will be able to understand this. So the real 6 sigma process is, the process variability is 12 sigma, minus 6 sigma and plus 6 sigma. If your tolerance is within that, your outliers will be at the end of the manufacture 3.4 parts out of 1 million parts produced. This is called a process capability. So this is also one of the requirements. See, in industries, to ensure this, in companies like BHEL, what we follow is quality first as our initiative. Quality means it's not only product quality. It is about process quality, and also it is about people quality. There are 3 P's in quality. One is product quality. What is the product quality? If you say that this is my mobile, the product quality, you know what are the characteristics. What are the characteristics of this mobile is defined based on the product quality, starting from dimensions, clarity, volume, and quickness, and storage capacity, etc., etc. How many cameras are there? How many SIMs can be introduced? And all those things are described as elements of product quality. Process quality in the industry which is making this phone, mobile, process quality is relevant. Process quality we'll talk about at the end of each process of making components of this mobile and also assembly of this mobile. There should be indices to determine the process quality at each and every stage with this index 3.4 out of 3.4 outliers out of 1 million parts produced in that particular process or stage of activity. So that is called a process quality. See, finally the product quality is a net, and the process quality is in terms of the continuous activities what are going on in making the product. Third one is people quality. To ensure both product quality and process quality, people have to be having adequate quality level in terms of, by that what I mean is they should have product knowledge, process knowledge, additional knowledge required when there is a change in the product, when there is a change in the process, and motivation to ensure that they are capable of ensuring all product quality requirements, etc. These are all called part of process quality, people quality. I would like to tell you one more thing. See, most of my points will be related to running an industry or working in an industry. Perhaps when you reach that stage shortly after all your graduation, you will understand in a better manner. Maybe that it will this information will give you some insight when you go there later. See, are you aware of what is the meaning of a defect? You are able to understand what is the meaning of. In simple language, I will tell you. If you go to for buying a shirt, even if a button is not there, that is a defect. Even some collar is having some issue, it is a defect. So like that, you can have your own terminology with respect to defect. So no defect is the ideal requirement for any product. Another extreme definition, other side, is fitness for use. Even without button, even with some problem in the collar, I can wear, but provided it satisfies the functional requirement. What is the functional requirement of a shirt? It has to give you cover, and it should give somewhat elegant look. It should not be looking ugly, etc. Some minimum requirements are there. That is a functional requirement. Depending upon the type of industry, that type of defect has got a bearing on the decision what you take about the acceptance of the product. In the consumer industry, in the between consumer industry and industry which is making industrial products, it's a vast difference. As far as boiler is concerned, even a small defect with respect to aesthetics, people will not mind. Whereas in the consumer industry, all such things will be viewed as a very serious one. So this is what is called the perception about the quality in terms of customer. Customer is different. Industrial product customer is different, and consumer product customer is different. So that is called a perception about quality. Another one is in the manufacture, You are making a product. If you make a product, definitely there will be some deviation in the course of manufacture of a product. If there are some issues, maybe your raw material is not all right, or your process line has undergone some breakdown, ultimately there is a problem in the product. And how to set right these things? In an established company, in an organizationally capable company, there is a system called a root cause analysis. I think you will be able to understand what is the meaning of root cause. You have to identify why root cause, why the defect has come. You should find out the reason. You have to list down, I think, Ishikawa diagram or fishbone diagram. That is also available in your statistics. You are, I think, you are familiar with that fishbone diagram or cause and effect diagram. You have to identify what are the root causes for the deviation. Out of the many causes, you have to identify only one cause. That is a major cause. That is called root cause. And then you have to eliminate the root cause. Eliminate the root cause. In simple real life terms, I will tell you, it's because most of the people are new to industrial environment. That's why I'm telling one real life example. Any cause which is leading to a deviation is called root cause. Suppose you are having your objective is to climb up. I think all are knowing about Rockfort. You have to climb up Rockfort. What is the effect? So I am a old man. I'm a little bit obese. So if I climb up, I may feel exhausted. I may feel exhausted. What is the problem? Exhaustion in climbing up. That's the problem. So how to eliminate this? I can take rest. That is elimination of root cause. That's a corrective action. That is, I can take rest. Suppose if they have some rest places in between 2-3 places, I can take rest and comfortably climb up. Still, in spite of that also, I may have exhaustion if I do not follow taking rest in between. You follow? The deviation is exhaustion during climbing up. And if you take rest in between properly in a systematic manner at 2-3 levels, so probably without exhaustion or without your feeling of breathing, you will reach the top. So corrective action is to take rest. There is one more higher level, preventive action. Suppose if a lift is there in Rockfort, or like Palani temple or any other temple, winch or some escalator, these things are there. What will happen? There's no chance for exhaustion. Simply go get into that, reach the top. So these are the 3 scenarios. These are all applicable to any defect or any deviation which will come up in the manufacturing cycle or in any company. A deviation is coming means how to correct the deviation should be known. How to avoid this deviation should be known. How to totally eradicate the deviation should be known. So correction, corrective action, preventive action. These are the 3 stages for manufacturing a quality product. That's about the second point. Now then, see, I will touch upon one more point and then I will go to roles and responsibilities of engineers in that excellent organization. See, the time given is about 10 minutes. I don't want to take more than another 5 minutes maximum. See, in any organization, there are some fundamental things which are called as strategic imperatives for the successful growth of an organization, successful establishment of an organization. For example, 5 such things are there, 6 such things are there. It will vary. I will just mention about 5 important points. I am only communicating with respect to a manufacturing industry. This is applicable to any type of manufacturing industry. whether electrical, mechanical, or even civil, anything, electronics. First one is safety. Safety practices to be followed in an industry. It could be any type of safety. It could be safety from electric shock. It could be safety to run under a high roof or walk under an high roof. Maybe some falling object may drop, and you have to wear helmet, safety shoe, etc. So safety culture is the first and foremost strategic imperative. The second one, probably, see, we can list down even 10. I am only just touching 5 numbers. Second one is a company should have a strategy. Strategy means that is a bigger word. Means what we are today, what we want to be tomorrow, so that we'll be able to manage well. Learning from the history of past. So you have to connect past, present, and future. So it's a mega level plan which has to be made at the higher level management involving senior level people, so that what I've learned in past, in what way it is helpful to today, so that what is going to happen. See, what is going to happen in future, there are a lot of uncertainties. Government policies will change. We may not get order. Customer will say, I don't want anything from BHEL, or there will be some huge employee turnover because some big company has come and they started giving higher salary. People will run. So all these things have to be accounted, and it is considered in a total manner, and evolve a strategy so that there is always an upswing, both in terms of top line and bottom line. Top line and bottom line means profitability and turnover. I think profitability is making profit, turnover means making the highest revenue. So both in terms of profitability and turnover, you should be able to maximize this. So this is what is called a strategy. Third one is called digitalization efforts. See, in nowadays, everything is becoming digital. The digital world, because nobody have ever thought of having a mobile some 20 years back. Now the mobile has come. Now people are wearing something and they are talking without even mobile. So like that, things are happening. And sometimes I will tell you the reality. In reality, in another 10 or 15 years, we may be seeing even movies in space without any theater. If you want to see movie like holograms. Like that, a lot of advancements are taking place. So digitalization has become a buzzword. Now, irrespective of the type of industry, digitalization efforts are encouraged, and only with that we'll be able to propel faster, and we'll be able to outbeat the competition elsewhere within the industry or outside the industry among some similar industries. So that is a third aspect. The fourth one is respect to humans, human resources. Earlier, now human resources are considered as partners. They are not considered as employees. So they are treated as partners. They are given due respect to train them, to acquire their talents, multi-skilling, and job rotation, all these management concepts. I think you are all reading a subject on management. In that, it would have been covered. So those things are relevant now, and they are gaining more importance. So only, see, both X theory and Y theory are required. Sometimes you have to use X theory to take care of the person who is not obeying, but at the same time, in a majority of cases, you have to support Y theory so that everybody will become self-propelled to give you wonderful output. So this is called fourth aspect. The final one is operational excellence. Operational excellence means whatever you do, whether it is small thing, whether it is bigger thing, whether it is mega-like thing, whatever it is, try to excel. Have a benchmark with a competitor, have a benchmark with your own colleague who has created a record, and try to beat that So that is called excellence, operational excellence. So these are all some 5 imperatives required. And anyway, we can list down another 5 also. And due to paucity of time, I am stopping with that. Now I am going to the second part, responsibility as engineers. See, first and foremost thing is adherence to rules and regulations, discipline. It starts from dress code to safety aspects and to attending office in time and respecting work schedules, targets, timelines, company policies, etc., etc. This is the first requirement. Second one is if you are in a design department, you should think of improving the design with respect to the earlier design in terms of producibility. You know what is the meaning of producibility? Producibility means you have some n machines. With n machines, you are able to produce an item, and the item will work well. And when you do the same item manufacture second time, you should improve the product so that by cutting down some 2-3 machines, you should be in a position to manufacture, or by adding additional features, you should be in a enhancement of material, enhancement of product enhancement. That is called product enhancement. So like that, depending upon the function, that is in the design department. If you are in the commercial department, you should have overall picture about the company, what is produced, how it can be produced, like that, and accordingly you have to meet the ultimate requirements of the clients. What are the requirements? There are stated needs, there are implied needs. Do you know the difference between stated needs of customer and implied needs of customer? Can anyone give one example so that it will become a interactive session? What is the difference between what is the difference between stated need? Example only. I am not expecting a definition. Stated need and implied need. Anyone real life example or some industrial example? Stated. Come on. Anybody? Yeah. Yeah. Correct. Yes. Extras. So, anything like that. So if you buy a shirt, you will give some additional things. So like that, you can think of any case. So the purpose of a contract person, commercial person, is to meet both stated needs and implied needs. The implied needs are actually many of the companies come up satisfying implied needs. Everybody should be in a position to satisfy stated need because it is an obligatory one. Whereas implied need is not an obligatory one, it is like a bonus. So this is what is the point with respect to a person who is working in. So then another important thing, there are different types of checks for any product. The check can be a dimensional check. Check can be a verification of parameters during the manufacturing activity, like temperature, pressure, voltage, current, etc., according to the type of process. And there are some checks called non-destructive examination. Without subjecting the part to undergo any destruction, a pressure vessel is there or a boiler is there. We do some radiographic testing, ultrasonic testing. That's a big subject. ND itself is a big subject. So like that, non-destructive, like that, many things are there in the industry. Okay. Then I want to tell about calibration. This is another important subject which is of interest in any industry. What is the meaning of calibration? I think the people in metrology, is there any subject for any of the branches, metrology? No. Calibration means, suppose I want to measure a voltage in a particular circuit, or I want to measure current, or I want to measure diameter of this piece. I will measure using some instrument, some vernier or micrometer or some voltmeter or ammeter. So whether that is correct or not, we do not know. For that only a calibration principle is there. Means the measuring equipment has to be matched with another master. For example, if it is a diameter, I will be checking the diameter of the workpiece. Similarly, to calibrate the instrument, that is micrometer or vernier used for the measurement of diameter, using a masterpiece for which the diameter is already known. Yeah. Yeah, calibration, that is more important. See, in a company like industrial products manufacturing company, it's a big it is playing a big role. See, without that, see, for calibration we are having a lot of standards also. That is ISO 17025, like that. It is a very big subject. So each and every parameter involved in a manufacturing industry has to be calibrated using masters, and the masters are traceable to some national norms or international norms. So this is the point with respect to calibration. Okay, we can talk endlessly. So due to paucity of time and strict constraint put on the time, I would like to stop here. Let's have any time later also. We will have a discussion, and even in EC also we can discuss. No problem. And with this, I would like to stop. Thank you for the opportunity given.
We are honored by the precious words of our esteemed guest of honor. Thank you, sir, for your valuable words. Now I'd like to call Ritul Mishra from second year ECE to welcome and introduce our honorable chief guest, Professor Shishir Sinha, sir.
Engineers have the magical power to create anything with their brains. Happy Engineers Day to such wonderful minds. On this tremendous occasion, it's my privilege to introduce us with our chief guest, Professor Shishir Sinha. He will be joining us online. Thank you, sir, for gracing us with your presence. Now, without any further ado, let me introduce you to our chief guest. Professor is the Director General at Central Institute of Petrochemicals Engineering and Technology under the Ministry of Chemicals and Fertilizers, Government of India. Prior to this, he was holding the position of Director at Kamla Nehru Institute of Technology, Sultanpur. Professor Shishir Sinha is a professor in the Department of Chemical Engineering, IIT Roorkee. He was also associated faculty in Center Excellence in Disaster Mitigation and Management, IIT Roorkee. He obtained his BTech, MTech, and PhD in chemical engineering from Harvard Butler Technological Institute, Kanpur, and IIT Kanpur, respectively. Professor has more than 24 years of academic and industrial research experience with more than 100 reputed publications, besides more than 132 in conference proceedings. Sir has also written 11 books with reputed publishers and has successfully completed over 22 high-impact projects and consultancies valued more than 152.79 million Indian rupees. Professor has developed 6 very popular online courses in the field of chemical engineering. He has formulated several national and international MOUs between IIT Roorkee and institute of repute like University of Strasbourg, University of Cranfield, RGPIT, etc. Professor is a fellow of Royal Society of Chemistry, Indian Institute of Chemical Engineers, Institute of Engineers, etc. Some of his research include polymer, res- polymer reaction engineering, polymer composites, ion exchangers, wastewater treatment for tanneries and petrochemical plants, development of eco-friendly engineering improvisers for carbon black, etc. Now, with this, I request Sir to please grace us with his remarkable words. Sir, please.
Thank you. And I hope that I am very much audible. Uh, I hope so.
Yes, sir, you're audible.
So thank you, Professor Sarma, for calling me. And I was just trying to pick out a window which I could have physically come down, but due to the lot of, you can see the variety of work engaged, I couldn't make it convenient. Anyway, very warm welcome and a very good afternoon to all of you. And as you know that we all gathered together to celebrate Engineers Day. Now, rightly said by this young student that the engineers, they are the mastermind of everything. And sometimes I used to have a debate in my family that doctors are more important or engineers. So, of course, whenever we start our day, the engineering products are encountered everywhere. And whenever we are wearing clothes, eating medicine and other things, everywhere you will find that engineers' role are even not only in Earth, we have reached to the moon, the Chandrayaan 3 mission. It's the best example of this one. And everywhere we are talking about the efficiency and other things. So the question arises, just I'm giving a brief outlook and then I will synchronize my small piece of lecture to the theme of this particular segment. That this particular day is celebrated. And you see that it is being celebrated in different countries on different dates, just to give an honor to the creation, whatever the engineers they are doing. But if you see, the most widely recognized engineers day is observed on September 15th in India, in commemorating the birthday of one of the India's greatest engineer, Sir M. Vishwasaraya. He was not only an exceptional engineer, but also a statesman and the recipient of the Bharat Ratna, that is India's highest civilian award. So, the Mokshagundam Vishwasaraya, he was a Sanskrit scholar. Also, he was you can say, the brilliant engineer. He completed his early education. Then he moved to the Bangalore for higher education. And in Pune, he joined the Science College to study engineering and was ranked in the examination in 1883. So he was a man of principle and who hold the belief that the technology and engineering, they are the cornerstone of nation building. Now, when I am talking about the concept of the nation building, it gives an impetus towards the world by our Honorable Prime Minister that we are intended to reach some extrillion economy. And trust me, without the engineering perspective, it is practically impossible to reach that particular economy. So based on that particular thing, and the basis of this one is the innovative ideas and the pioneer work being given by uh, Professor Dr. M. Vishwasaraya. Now, when we talk about the engineering perspective, we usually the celebration of the day, it is not only just to mark a respect to Sir M. Vishwasaraya, but it is the mark of respect to every engineer. Those who are the budding engineer, those who have completed their professional journey. So everywhere it involves. So it gives an honor to those unsung heroes of our society, and those are the engineers. Now, this particular Engineer Day theme, 2023, every year there is a theme of this Engineer Day. Now, engineering for a sustainable future, usually focusing on finding innovative solution to the environmental challenges. Now, since all of you are a budding engineer and a lot of hope are vested with you, so I always insist my student to keep focus on two different things. One is the E's, another one is R's. The E's are energy, environment, and economics. Because without economics, nothing is possible. And everywhere, if you go to the market, every time you need to focus that I should get an optimized product at a compatible price. Environment, without environment consideration, it is practically impossible to live in the sustainable world. And energy. So all these things are compatible to each other. Now, when we talk about R's, this is again very important. There are so many buzzwords now people are talking about, like recycling, reuse, refurbish, re-engineering, relook. But it is the responsibility of the engineers to go for rethinking. Trust me, please emphasize in the rethinking, whether it is usable or not. Are we giving a proper justification or a justice to a particular thing? So rethink is always gives you a better idea. So when we talk about with respect to the theme of this particular engineering day, the sustainability, as I told you, that sustainability is practically impossible without the optimization of RE, which I narrated just a couple of minutes ago. Now, when we talk about the engineering perspective, or as we stand here today, let us take a moment to look around and realize the incredible impact of engineering in our lives. I told you that our day-to-day affairs without engineering product, practically life is impossible. Even the medicine people can't do anything without the engineering people, like thermometer or X-ray machine, or whatever you think about, without engineering perspective, it is practically impossible. So, in a generic term, from the moment we wake up to the time when we lay down to the rest, engineering surrounds us. It's in the roads we travel, the building we inhabit, and the gadget we can't live without it, and the medical marvels to save our lives. But beyond the concrete and the steel, engineers build something even more profound, that they build dreams. When we are talking about 2047 economy, when we are thinking about the 2047, then trust me, the country is having a lot of hopes with respect to the engineering perspective. Be optimistic. Now, the engineers, they transform the idea into reality. The making impossible seems ordinary. They are the architect of the progress and the visionaries who propel us into the future. So the engineers are the bridge between what is and what could be. So we need to look into all these aspects. Now, sometimes it's quite easy to forget the passion and dedication that lie at the heart of engineering. It's easy to overlook the sleepless nights, the, the relentless problems in solving, and the burning desire to make the world a better place. Engineers, they are not only the creators of machine, they are the creators of change, they are the creators of hope, they are the creators of future. So if you have a plot, you need to construct a building, then ultimately it's a civil engineer, electrical engineer, all those they participate in an equal fashion to build an empire. Now, class, as we celebrate Engineers Day, let us remember the giant who walked before us, like M. Vishwasaraya, whose legacy still inspires us today. And let us also recognize the unsung hero, the engineers who work tirelessly beyond the scenes and making our lives safer, more comfortable, and more connected. Like if you travel in an airship or train everywhere, just give a thought that how much pain and how much effort and how much thinking is there with respect to the engineering perspective. This day is not only just about celebrating the past or the present, it's about the nurturing the engineers of the future. It's about igniting the spark of curiosity and innovation in the heart of our young minds. It's about telling engineers that they hold the keys to unlock the brighter future or brighter tomorrow. To the present student, I say this, consider the path of engineering. It's not only just a career, it's a calling. It's a chance to be the part of something bigger than yourself, a chance to leave a lasting impact on the world. It's a journey to discover, a journey of creation, a journey of hope. Engineering is, you see, that not just about the equation, etc. It's about the imagination and the creativity. It's about the relentless pursuit of the solution and audacity of the dream to think big. Engineering is a testament to human potential, a reminder that we are capable of greatness. Now, more than ever, our role of engineers is vital, from addressing climate change to the pollution, to ensuring the equality through access of technology. There is not an area where engineering cannot make a difference. Among the challenges, like if you see the pandemic, we see how medical technology, artificial intelligence, and data analysis play a heroic role, and behind all this are engineers. See, people clapped a lot for the doctors, but you see that there are countless engineers effort, like whether you talk about the ventilators, whether you talk about the mask, whether you talk about the so many things, even the packaging of those vaccines, the preservation of all those vaccines, everywhere engineering perspective was involved. So we must recognize the efforts put on by those engineers. Now, the journey of engineering is always evolving. New challenges come, new solutions, new ideas, they are forged from new problems. Now, our task is never complete. For every end is the beginning of a new journey. However, as engineer, we must remember that the core of our work should be commitment to the betterment of human lives and the welfare of our planet. Now, at the end of my speech, I wish to leave you all with one thought. As engineers, we are the architect of future. Our dreams and abilities shape the world of tomorrow. Let's strive to bring positive changes and create a world that future generation will be proud to inherit. Thank you, and a very happy Engineers Day to each and every one of you. Jai Hind.
That was an inspiring speech, sir. Thank you for the influential message. It is the time that we acknowledge and felicitate the winners and runners up of quiz and coding contest held on the occasion of Engineers Day. I request the director, sir, to distribute the certificates of the winners and the guest of honor to distribute the certificates to the winners of quiz and competitive coding contest. The winners of the competitive coding contest are Rishabh Lalwani and Ravish Kumar. Now we go on with the winners of the quiz competition. First prize goes to Team Conquerors. Team members are Utkarsh Shukla, Rohit Upadhyaya and Aviraj Joshi. And second prize goes to Team Andere Mein Tir. Team members are Nidhi Vishwakarma, Ven Arya, and Nandini Sonekar. Thank you, sir. Here we come up with the closure of today's astounding event. We got to learn so much from the knowledgeable speeches by our honorable chief guest and our guest of honor. Now I'd like to invite Honorable Director Sir Professor N.V.S.N. Sharma to deliver the closing remarks.
Yeah, good evening, Professor Shinna, Dr. Gurunathan, Dr. Anup, and other colleagues and dear students. Happy engineers to one and all assembled here. And you have heard two important people who are very, very successful. One in the academics come academic administration, Professor Sinha, and Dr. Gurunathan as an industry person. So I think you know what is the role of an engineer, how successful people can be in different ways. And as Professor Sinha was mentioning, the next 25 years is for India. Please remember, it is our time now. Okay, we have been waiting for this for the last 75 years, and the time has come now. And the next 25 years, you people will have huge amount of opportunities within India under the scheme of this Atmanirbhar Bharat and other schemes. So please get ready and get equipped with your necessary skills for this and make India to be the number one. We are now almost at number 4. So I would like to see whether I'll be staying up to 27 or not. 99% I'll not be there, but most probably 2047 onwards, we'll see that India is the number one, and you are all going to enjoy the fruits of it. So wish you all the best towards those things, and thanks to the Professor Sinha, in spite of his busy schedule, actually he was parallel attending another meeting. That's what he was telling me also. But no problem, but meeting students is always fun for all the teachers. So he readily agreed and joined. So thank you. Even in this short notice, I made it for you. And it's our good friendship that made all the things for us. And Dr. Gurunathan Garu, very much thank you to making making the things clear to the students. What are the things that they are supposed to do? First and foremost thing itself, I would like to remind, the dress code is the one which they follow. That's why we also insist as a training of that towards that to maintain good dress code, punctuality, and all these things. And don't expect that it's being followed only in production companies like BHEL or other PSUs. Even in software industry also, they definitely maintain very good dress code and all these sort of things. Very neat and clear, okay. Formal way of doing things is very, very essential. So dress code really brings the seriousness of the job what you are doing, the dedication, the possessiveness that yes, this is my job, I should do it in a very systematic manner. That's where all the things happen. Don't expect that we are forcing you. Okay, so it's a part of the training only. So please do maintain such things, and wish you all the best for the next day of the evening. Happy engineers to one and all. Thank you.
It is the time for the felicitation of our esteemed guest of honor. So I'd like to call Director Sir and Dr. Anup Jacob Sir to felicitate our chief guest.
Interaction is more important compared to all those things.
Now I would like to call upon Ritul Mishra to deliver vote of thanks.
On behalf of IIIT Trichy, I would like to extend our sincere gratitude to our esteemed guest of honor, Dr. T. Gurunathan, and our respected chief guest, Professor Shishir Sinha, as well as Honorable Director Sir, for embracing us with their presence today by sharing their valuable time and experiences. Your presence made this occasion truly remarkable. Our heartfelt thanks to the organizing committee, faculty head, volunteers, and everyone who worked tirelessly behind the scenes to ensure the event's success. In conclusion, your support and enthusiasm has made this event a resounding success. We look forward to more such events in the future. Thank you once again for being a part of this event.
Now, I'd like to request you all to please stand up for the national anthem.
गण गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्तर गंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय 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 हे